amazing. I
Black
love
screen.
It.
Nope,
It's
I
not
got
black.
it. It's good.
I have a black screen.
Okay, here we go. So what is a pointer?
It's a thing that does pointing.
It does point. Very good, very good.
So like your pointer finger. Oh, it's pointing.
No, we've talked about variables and structures and objects, and all of these things exist in memory somewhere, right? When we create a variable num, that variable is assigned someplace in the memory. And every place in memory has an address, right? Just like all your homes have an address, we're going to every memory location has an address, and so every variable has an address. And sometimes it can be useful to know or to point to the address, to access the address of a variable rather than the variable itself. And so that is what a pointer is. It is a variable that stores an address. Now, that may not sound very cool or very interesting or even very useful, but pointers are the most powerful thing about C++. This is what makes it better than all the other languages, or one of the things that does.
Biased, so.
Oh, very biased, but I am also right, so it's okay.
How do you know
All
if
teachers
you're
think
biased?
they're always right.
No, pointers are a cool feature you don't get in a lot of languages like Java or C#, or any scripting language that I know of. But if you can access the address of something, you can do a lot of cool things. It gives you an incredible amount of power, and so they're really a two-edged sword. They give you a lot of power, but they also open the doors for a lot of bugs and a lot of problems. But yeah, really a lot of fun, but can be a lot of trouble. Let's look at the book here. This is a picture of what I was just talking about. We've got a picture of the RAM, the memory, system memory here. You've got your program made up of all of its variables and objects. They're occupying some part of that memory. If we were to zoom in on that, we would see that every variable, now here he did this wrong, but every variable has an address, and they're
Did that wrong.
just all lined up in the memory. Do you know why this is wrong?
Because it's not going up by 4, 8, 2, whatever.
Right.
It's up by 1.
Character is 1, so that's fine. Actually, integer is not, it's based on the operating system, so technically it could be right in some systems, but on every modern system that I have seen, an integer occupies 4 bytes. Right here it shows the float occupying 4 bytes. But that's how it looks. And every one of these guys has a big address. And so our pointer will contain one of these numbers. Make sense? Pointer is ultimately just an integer, but it is an address to something. So let's look at that in the code. I've got some variable, and then I can create a pointer to that variable. I can say I want a variable that is a pointer, and that's what the asterisk means there. That's not multiplication. That is to say that this is not an integer, it is an integer pointer. Now you can put it there, you can put it there, or it doesn't really matter how the spacing falls. Compiler sees it as all the same, so I just do it like that. And the pointer can equal the address of any integer. If it's an integer pointer, it points at an integer. Make sense? We could have, maybe our variable is a char. Let's call it C, and it equals some character. Then you could create a char pointer. Set that equal to the address of C.
You forgot something.
Forgot the name. We can do it with objects as well. If we want, we could include string. I can create a string str. I can say, str equals something. And then I can create a string pointer. And set that to point at that string. Now, this is a char pointer, this is an integer pointer, this is a string pointer. They're all only containing some address, one of the numbers in the memory, showing wherever that variable is stored. Alright, now that's simple, but keep that in mind. The can of worms this open will take you all kinds of strange places. But always remember, when you're really confused, that a pointer is just an address. It's just an address. Alright, notice I put the ampersand here. That is the address of operator. If you forget that, you'll get an error, because a pointer cannot be a string. It must be the address. It must be the address of a string. What about our own objects? What if we've got a class or a structure, either one? And then I want to create a boat. I'm just going to scrap all of these guys. Boat. Create a boat like that. We're familiar with this. I can use the dot operator to access those guys. Say boat dot weight or something like that. Right? We know these. We can create a boat pointer. And you can name these pointers whatever you want. I'm just sticking with this convention right now. And what would I set that equal to?
Boat. And boat.
Address of the boat. Now I've got a pointer that's pointing at the boat. Super cool, right? You're like, well, I don't see the point in this. This is dumb. We'll get there. Stick with me. We'll get there. All right, more rules. Now, when we do it this way, you can no longer say, well, I'll tell you what if I want to, what if I want to change the weight or the name of the boat using the pointer? I can't say dot. What's a good boat name? You can't use the dot operator if you're working with a pointer. Instead, you're going to use the arrow.
Because you're pointing.
Yes, because you're pointing. But you can change the boat using the pointer. But instead of using the dot, you must use the arrow. And then just to make sure that this is working correctly, we can do a cout boat.name. And we should see Queen Anne's Revenge. Maybe. I didn't set the system. You're right.
Just what sets things off right
It is. Epic fail. There we go. So we have set it indirectly using the address. All right, I'm gonna take a step back. Let's go back to our integer here. We have an int num. We have an int pointer, PTR, that's pointing at num. We can also change num using that pointer. It's a little bit different. We're not going to use an arrow because we're not going through a structure. But we say PTR. Tell you what if we just do cout PTR? Yes, there's the address in hex. In hexadecimal, that is where num resides this time when I run the program. Now, next time I run the program, it may be somewhere else, but that's what I get on my machine this time. If I want to actually see what the pointer is pointing at, we use a dereference operator. Oddly enough, it is the same as the pointer operator and the multiplication operator. But now, in this context, this is known as the dereference operator. We dereference the pointer, saying, hey, don't tell me what your value is, tell me what you're pointing at. What is at that actual address?
Garbage.
And it will show us the garbage, because we never set num. So if we set num.
So I have a question.
Yes.
Why is it the same for making a pointer and dereferencing? Because isn't the pointer referencing num?
Isn't the pointer referencing num?
Referencing the address of num, which is num. Why would they use the same symbol?
I have no idea. I know it works. There's no conflict, except for in your own mind.
That's where it matters.
Yeah, that's true. But you can get past that. So, just like before, if we wanted to see the address of something, we could say, show me the address of num. I run that. We can say, show me. It's kind of going the opposite direction of show me the address of. You're saying, hey, show me what's at that address. You do dereference. You give it an address, and you can see what's there. How's that feel? Simple? We get it? It's just a variable that stores an address. We can access it using the dereference operator. We can access what is at an address using the dereference operator. Now, why would we need something like this?
Because you want to pretend to be special. With great power comes great responsibility.
I will answer your question with a question. Can it change variables inside of classes?
It can.
Well, private ones.
Oh, it can. We could change stuff in programs that are not even ours. That little pointer can run rampant through memory, doing whatever. It will usually cause things to crash, but you can do it if you know what you're doing. The pointer can go anywhere in the memory.
You just have to have the address.
Well, yeah, you can. I'll show you in a minute. We will let a pointer run wild through the memory, and we'll see what it uncovers.
A lot of garbage.
But no, there's actually a reason for this. A more practical reason.
You need besides hacking.
Besides hacking, although they're definitely useful for that. You have two areas of the memory. One is called the stack, and the other is called the heap. So far, everything we have done is on the stack. Now, the stack is small. It's like that image that it shows there in the book. You've got your variables with their names. Every variable has an address, and every variable has a value. right? This is our little stack that we use in main. We call this the main stack frame. So num is here. He's chilling out at some address. We'll say it's like 100. It's actually a lot bigger than that, but 100 is fine. And he's got a value. 999. We have another variable here on the stack. It's called PTR. What's its address? Probably
104.
104. What's its value?
The address of num.
Which is 100. You get it. This is cool. Stack is great. It's really fast. I can tell my program, hey, fetch me num, and it will go right to it and say, yes, 999. But how much memory is in that computer?
Very little.
No, in the computer. We've got 16 gigabytes of RAM in these computers.
Exactly, very little.
By default, your stack is 1 megabyte. In Visual Studio, you get 1 megabyte to work here. What if I have a really cool song I want to put in my program and it's 3 megabyte MP3? Does that work on our 1 megabyte stack? Doesn't. But lots of programs have music, right? What if I've got a cool video? What if I've got a bunch of images that are bigger than a megabyte? This does not work. Okay, you run out of RAM. You'll get a stack overflow real quick. So anything like that, we have another section of memory called the heap. It is just an enormous sea of memory out there. That's most of the 16 gigs that you have in these machines. And it is not managed by the program. It's managed by you, the programmer, for the most part. Okay? So if we do have something really big, like an image or music or something like that, that's occupying several megabytes, we can stick it out here on the heap. But then how do we get to it? How do we say, hey, play my song? And our program's like, I don't know where your song is.
And the address.
Well, we've got the address of it. We can store that right here. Right? We can have PTR2. It'll have someone address, not important. But then it can also have this address out here. Maybe this is 2000 or something. Right now, our pointer fits on our stack just fine. It keeps the address of the big object, and you can access the heap now. And now your program can grow as big as the memory will allow it.
And to be strictly pointers and not space.
We'll get to that later. Just FYI, 32-bit programs, because 32 bits can only store so big of a number, you get 2 gigabytes of RAM to work with. Right after that, your program will crash. You're out of memory in a 32-bit program. Go up to 64-bit programs, compile in 64 bits, you get a lot more memory, a whole lot more. So you can use the whole 16 gigs, 32 gigs, whatever you have on there. That's one of the differences between 32-bit builds and 64-bit builds.
Get a 64 basically.
Most programs don't need that unless you're running a game with a lot of intense graphics, or a lot of music files, or you're reading in enormous amounts of data from the internet or something like that. You're fine with 32, but if the program gets big, 64 bits great. But this is the reason we have pointers. This is like the beauty of it, is that you can now access the heap and store your pointer right here, and that works out just fine. If you're programming in Java or I think C#, most scripting languages only use the heap. Everything is on the heap, and it just manages it all for you. And that's one of the reasons why those languages are slower. But you, the programmer, in C++ can do this manually. You can put your stuff out there on the heap as long as you take care of it. Now, if for whatever reason I lose this address, let's say I messed up and accidentally assigned PTR2 to num. So, yeah, 100 here. Now, what has happened to my music?
It's out there.
It's still out there. And this memory is still occupied. And this is what we call a memory leak, because we have no way of getting this back. So for turning off your computer, the operating system will go out there and clean up the memory and allow it to be reallocated. But as long as your program is running, it knows that this belongs to your program, but it doesn't know where it is. And you will get memory leaks, you will get heap corruption. There's some other problems that you get if you don't take care of this guy. So if you're going to allocate memory on the heap, it is important that you delete that memory whenever you're done using it. Okay? This is kind of like a needle in a haystack kind of thing. If you throw a needle in a haystack and you've got a thread attached to it, how hard is it to find the needle?
Pull the thread.
You pull the thread, it's right there, got it. But if you lose your thread, or you pull the thread out of the needle, oh man,
The Mythbusters way.
now you're screwed. So that's how this works. So how do we access the heap? With the pointer. Let's put a boat on the heap. If you're going to do it on the heap, you just start with the pointer right off the bat. You don't need to create the boat and then put it on the heap. You can do it all in one go. You say a boat pointer, I'll call it boat BTR, equals, and then we'll use the keyword new. And you follow that up with the word boat. Alright, this will invoke the constructor of the boat, and it will create, actually new is doing all of this, it will invoke the constructor of the boat, it creates the boat on the heap, and it returns the address. Because it returns the address, it must have a pointer to store that in. So if you get, an error like this, it's probably because you forgot that new returns a pointer. New returns an address. So we must assign it to a pointer. Alright, there's my boat out there on the heap. And I can access it the same way I did earlier. I can say boat PTR dot name not dot arrow, because it's a pointer. Equals something, and boat PTR weight equals something.
I love that model. It's the best out there.
Yeah, it is. And there's our boat. And then we will always access our boat using the boat pointer. Now, if I were to do something like this. What has happened?
You don't have a pointer to it.
Here's what I did. I went out and I created the second boat somewhere on the heap. And let's say it's at 3,000. And I assign that same pointer now to 3,000. So I've got a pointer to this boat, but this guy is lost. Lost in sea, yeah. He's totally lost. That's a memory leak. That is a memory leak. And your program will be doomed.
What did it do from the start?
A really bad is whenever you're doing something like this in a loop. You do something like this in a loop, then the boat's constantly just being created. Non-stop boats. Can you see this over here on the right? My process memory?
Yeah.
Look at that thing climbing.
There's a lot of boats.
Lots of boats. Tons of boats.
Can I have them all?
We're going to fill the whole memory up with boats.
Well,
And boom, we crashed and burned. We ran out of memory. 32-bit program, I hit 2 gigabytes. I'm done.
Did you light a fire?
I have no idea.
we don't know what happened with the boats now.
We got a bad memory allocation error there. Yeah, that's a memory leak. That is a memory leak. So, how do we prevent this? one, you don't ever want to load stuff like that. Well, I won't say never, but most of the time you don't want to do something like that in a loop. You load them outside the loop, and then you do logic and math and things like that inside the loop. But to clean this up, if we are done with the boat and we want to return that memory to the system, we use delete. Delete.
God, it's so simple.
Delete is the partner of new.
I thought old was the partner.
Well, you were wrong. Deleting the boat will free it up, and so then I'm going to kill the program. That deallocates the memory. New allocates memory, delete frees up the memory. Now if we run our loop,
We gotta run that first.
that would also be a problem. I can create a boat and delete a boat indefinitely. While that's not really a good programming practice, my program is stable.
You lost your first code though.
Yeah, the first one's gone, but the rest of them are fine. I had one boat is lost.
Make a fleet of boats.
That's still
All
bad.
kill themselves.
That's still bad to lose anything. You don't want any memory leaks at all. But that would work, and this should be stable. Yeah, I'm not on that 45-degree incline right there. My memory is just stable.
What did you mean by letting a pointer run wild at the moment?
Oh, okay, let's do that. But these are the basics. This is what a pointer is. It's an address, and this is why we need it, so we can get to the heap. That's the main thing. Now, there's tons of other applications, but you can't get to the heap without a pointer. Not really. Technically, global variables are on the heap, but otherwise, this is the normal way of using them. So I said something about a pointer running wild in the memory. Let's do it.
Yes.
Something about pointers is they follow some rules of arithmetic. We said that if we have a number and an integer pointer here, that both of these guys are occupying 4 bytes. And if it's an integer pointer, I can do math with it. I can say pointer plus plus. And that will move my pointer 4 bytes in memory.
Wouldn't that just be the pointer?
Yeah, that's the pointer.
The pointer.
So if num is at 100 now after plus plus, it will be at 104. Now it would be at 108. And it will continue to go by 4 because it is an integer pointer. Now if we make it a double, it will jump 8 at a time. It's giving me an error because num's not a double, but there you go. Now it will hop 8 at a time. And if it was a pointer to a boat, it would check out how big a boat is and it would hop that many at a time. And this is good for going through arrays, right? Because arrays are all lined up in the memory. That is one of the things that are one of the properties of an array, is that they're all side by side in the memory. So you can have a pointer to one, and then you can iterate through them really easy using the arithmetic. Pointer arithmetic. Okay, so based on that, I can go plus plus through the memory as many times as I want, right?
Yep.
So
Do that.
let's do something crazy. Here's our char pointer
1.
pointing at num. Yeah, let's loop it. Let's do an infinite loop here. We'll see out whatever this pointer is pointing at, and then we'll bump it up by 1. Now, this is going to give me the address, so how do I get the character? It's going to treat every byte as if it's a character, and it's going to try to display that to the screen. If you want to do that, you dereference. Don't show me the address, show me what is at that address. All right, let's try to run that.
Microsoft Windows HTTP.
Okay, it treated everything like a character. These are probably Unicode characters, maybe, and that's why there's a space between each one. Maybe. I don't know. Yeah, you see that some of this is readable. Tooltips.
This box. Oh, you got the visual.
I was about to say, is this the Microsoft classes or whatever?
No, this is somebody else's program. It's not my program.
It's probably pulling at least some of it from Visual Studios, because I saw list button or button list box.
You don't know when you run your program. You don't know where in the memory it's going to say, "Hey, your program goes right here." All right, and it could be right next to other important programs that are running in the operating system.
Windows Common Control.
Sure.
Got resources.
Hey, look! I found a public key token.
You're a hacker.
Wonder what else you could find. Yeah.
Passwords.
Maybe. Yeah.
Probably.
And so that you can see all of a sudden how powerful being able to work with pointers can be. I don't know why it crashed. Not only can you read things in memory like this, you can change things in memory in a similar fashion. It could be pretty destructive. So
Change one letter, the entire computer crashes.
maybe.
Isolation, automation.
Let's try it again. Let's go backwards this time. Man, it's going a lot farther.
It's a lot of blanks.
It's a lot of empty memory. We may be out in the heat by now. Who knows?
I think you're in the heat.
I have no idea.
Oh, there we go.
We're reading it all backwards now. So you can see it's all written backwards since our pointer's running backwards. Anyways, you get the idea. So that's cool stuff. No, normally you don't use them that way. You normally don't want pointers running wild through the memory. But you can do that. That's what they are. When you can access an address, you can go just about anywhere. And you can toy with just about anything. I think that's a good intro for now. Like I said, this is just barely scratching the surface of what pointers are used for and why they're essential. And it seems like an abstract thing right now, or kind of a weird thing, a weird facet of C++. This becomes the norm. Okay, we use pointers all the time, and it just becomes second nature to you eventually. So don't shy away from it. This doesn't go away. Embrace the madness, because this is where programming really begins.